So first, a short introduction for those of you who were not here on my session last year. So I'm Viktor. I work for CloudBees. We're a company behind Jenkins. You know what Jenkins is, I hope. If you don't, shame. I'm also one of the Docker captains, so I'm very much into continuous delivery, continuous deployment, microservices, containers, schedulers, other stuff, right? Write my blog, read it. There are some online courses, pay for it. YouTube videos, books, and so on and so on. In other words, I'm very huge amount of my time is spent into teaching, preaching in communities throughout the world. So now let's start with why am I here? Besides the obvious reason, it's a conference, right? And I'm supposed to talk about something. So a few months ago, before I went to San Francisco to give another talk, I went to a mountain, relaxing time, trying to clear up my mind and all those things. And then all of a sudden, whole mountain went ablaze. That's US, so that's their equivalent of a burning bush. So anyway, a voice told me, I need to tell you, you are really led astray with the way how you do your software programming, your practices. So it put me in charge to pass you, gave me those 2 stones, 10 commandments. However, I couldn't bring it here. Your boarding police is not really happy with that. But anyway, before I continue, I need to give you a disclaimer. These are not what you're going to hear, does not represent what my company is teaching and preaching. It does not even represent my views. It's 10 commandments, those are his views. So if you have any problem with what I'm talking, if I'm not politically correct, speak to the guy, please. So who is practicing continuous delivery, continuous deployment? 2. And two of the 4 are not even from this country. What's wrong with you people? Okay, 3. Now we're fine. Now it's okay. Now we reach 1%, critical mass. Anyway, continuous delivery is all one of the big, I think, movements or practices that we are experiencing last maybe 5 years or something like that. Especially since we all realize that continuous integration is just not enough. Do you know what continuous delivery is? Not even that. What's wrong with this country? Shy. Okay, I'll ask you again at the end. So what is continuous delivery, right? The best way how to explain this, I don't have a picture for this slide because it's offensive. It's like having sex when you're a teenager. No, sorry, lovemaking when you're a teenager. So what are the characteristics when you were in high school and sex? First of all, everybody talked about it, right? At least when I was young. I don't know how it's with younger generations, but 25 years ago, 30 years ago, everybody talked about love. And now the result is that actually nobody knew what that is. Nobody did it when I was 16, 17, something like that. But since everybody was talking about it, everybody thought that everybody else was doing it. So everybody else had to claim that they're doing it as well, because you don't want to be the only one who is not doing it, or at least to think that others to think that you're not doing it. Because if that happens, if you were not claiming that you were doing it when you were young, then you probably ended up like a software engineer. Introvert, right? I'm probably in a wrong conference to speak about those things. Anyway, so why do we want continuous delivery? There are quite a few benefits, I mean, huge benefits. One of them is that it reduces deployment risk. Because there is that misconception that I think that everybody is starting to understand or already understood, misconception that if we plan something for half a year and then spend half a year developing and then spend half a year testing and then another 4 months integrating and then we put it to production, that's going to be more secure, right? Because we planned everything in advance. We did everything we should. The reality, at least the reality when you compare it with so big software companies that know what they're doing, most big companies don't know what they're doing to begin with. But those that do, is actually the faster you deploy, the risks are smaller. And there is a very easy explanation for that, because if you code for 3 hours and then commit that to Git, let's say, SVN if you're unfortunate, and that gets to deploy to production 15 minutes later, you realistically reduce the risk drastically, because you change 30 lines of code. Even if there is something wrong, it will impact only a small, tiny fragment of your system, and you will be able to fix it very fast. Now, maybe that's because I'm relatively old, but I cannot remember what I did 3 months ago, and then when it fails in production to fix it. It's just impossible. You need to spend a huge amount of time to try to even remember what you did long time ago. When it's deployed continuously, when it's deployed every single day, then things get much, much smoother, assuming that you have good practices in place, that you have a lot of automation and all those things. Now, the second obvious is that it's increased speed of delivery, because realistically, business wants you to deliver a feature as soon as possible. There is really not much reason to wait for another 500 features to be developed until that feature is there, right? The sooner you deploy, the sooner you start getting revenue from what you did. Developers are happy because developers want to see their stuff in production. Business is happy because they start getting money. Testers are usually and operations are not happy, but we can fix that. Faster user feedback, because if you develop continuously, you're going to get the continuous feedback from your users. You will know what to do next. Instead of you guessing what are the next 50 different features that my users want, you just get feedback continuously from your users and adapt, right? There is no real planning in advance. There is no planning 1-year project or anything like that. Short iterations, deploy to production every day, every hour, every minute, whatever is your frequency, get feedback, iterate, improve. And this is one that I really like, and that's kind of, there were quite a few talks about Agile today here, and to me, something working in production is the only definition of done, right? Everything else is faking, kind of like, oh, this is done, but it needs to be tested, and this and that and stuff like that, right? When something is developed, when something is tested, it is deployed to production, it works, then it's really done. That's the only real measurement I have with the teams I work with. How do we define done? It's a feature, it's in production, then it's done. Anything else is just noise. It increases quality because people cannot rely on unreliable methodologies and processes and other things. You need to really step up your game if you want to apply something like this. And the result of that is really increased quality and repeatability and many other things. And finally, decreased costs. This is also one that I really, really like, is that finally, once you get out of the way all the manual repetitive tasks that nobody really wants to do, but everybody's doing, then actually your teams, your people can spend time on producing something that brings value. Like running the same set of tests over and over again manually does not bring value, because machines are good at doing repetitive things all over again. What really brings value in our job is when we do a different thing, solving a new challenge every single day. That brings value. Solving the challenge that we solved yesterday brings no value, right? Assuming that we have machines that can do that. So really, I will assume that you're shy, nobody lifted hands, but at least with other teams when I speak, everybody really wants to get somehow closer, if not there, with continuous delivery or continuous deployment. By the way, actually, I just realized that I forgot to define what it is. Continuous deployment is when every commit goes to production. Automated, without manual interaction, very easy. So everybody really wants it, most of it. Just like love, everybody's claiming that they're doing it. Most of the companies I've worked with, they failed one way or another. An even bigger percentage of them are faking it. Just like we have a tendency to fake that we did everything. That was a hype, right? Every company today is agile, and then you go there and realize that most of them are not, right? And same thing goes, and everybody wants big data, and they have logs, right? That's not big data. And the same thing happens with continuous delivery. When I go and speak with teams, with customers, with companies, yeah, we are doing continuous integration, continuous delivery, and then you dig their system and realize that they're not even close, right? But if you're one of those who lifted your hands and say, we are doing it, and you're not lying, then you're really in a small minority today, at least compared to the industry as a whole. then you must be working in Google, Apple, not the whole Apple, but part of it. Anyway, so let's see what he told me to pass the message to you guys. 10 things. I don't know why, but it always needs to be 10. It cannot be 8. It cannot be 9. It cannot be 11. 10 commandments. So the first one is that you need to be agile, right? It's almost silly to even try to go towards continuous delivery if you're not agile. And when I say agile, I mean who's agile here? Who works in agile environment, right? Okay. And those of you who said that you're agile, do you have a testing department? Nobody. You do. You're not agile. Kind of. The problem in testing, the operations department, whatever. The problem with how we implement agile is that we have a tendency to first of all, step one, becoming agile. I'm going to give you a quick course, three-minute course how to become agile. First step, rename all the roles. So whomever is a manager becomes a product owner, right? And whomever is, what else? Business analyst becomes, business analyst becomes product owner and manager, scrum master, right? Rename a few other names and then you'll be, and you need to have stand-ups. Every single day, 15 minutes. That's an exercise, right? Stand for 15 minutes and talk about things. Anyway, the reality is that even though companies are adopting Agile, they're really having a really hard time to dismantle the silos, right? To dismantle those companies within companies, those departments that are very, very focused on a tiny element of the big picture, and prevent the teams from continuously moving towards their goal, whatever the goal is. And the goal is actually to have something in production, so it's not whatever the goal is, towards moving to production, right? Because every time you need to pass something from one department to another, you are introducing lean time, you're introducing waiting time, you need to open Jira tickets and then pass through hoops and then jump and go down and then wait for 3 weeks and then something happens and then you can continue, right? So one of the prerequisites is to remove those silos and start forming teams that can work without waiting for anybody else, right? That's in a nutshell. So, and that's basically what Agile is, at least my understanding. Rocco might disagree with me, but it's about not waiting for, giving power to teams to do the stuff. Empowering people and dispowering, if that word exists, decision makers on the top that are completely disconnected with us. Huh? As long as developers have contact with those clients, yes. When there are 57 layers between you and the client, then you can empower them as much as you want. The second thing is you need to refactor. Who of you has an application that is more than 5 years old? No, everybody is, what, like 2 to 3 quarters of you are startups, right? You just started yesterday. This is all, I feel ashamed now. I don't know what to tell you guys. Anyway, for those few of you, the rest is very lucky. You started yesterday and you don't have legacy code. You don't have problems. I don't know why you're not doing continuous deployment then, but that's a separate issue. Anyway, it's very important that you cannot really keep going with your applications that are 10 years old, that are not designed to be buildable, to be testable, to be deployable, and all abbles that you can imagine, right? Because if you don't adopt refactoring as part of your process, then you end up with a big pile of art. It is art. That cannot be tested, cannot be deployed, cannot be done much with it, right? And we spend most of our time fighting with it. Actually, I would even say that those of you who are developers in this group, if you don't spend 1/3 of your time refactoring, and by refactoring, I don't mean that's the definition, improving your code without adding new features, you're doing a horrible job. You're not doing a good job, right? Just adding new features, piling is not sustainable. It cannot last long, right? So you need to adopt refactoring, re-architecturing as part of your daily work. The next one is, I've seen a lot that there Then once companies want to adopt continuous integration, continuous deployment, DevOps, Agile, whatever, then first thing is that they do is they create a department, right? So we have a department that's going to create continuous delivery pipelines for all the teams in our company, right? Or we're gonna, it's similar what's happening with DevOps now. We're going to create a DevOps department. Such a thing does not exist. But we're going to create a DevOps department. Same thing with continuous integration, delivery, deployment. They create departments. And that means that actually the previous slide does not work, because if you're not doing it yourself as a developer or member of a team, you don't know how to do it, and your code will be this. So you need to adopt those practices yourself. You cannot rely on a separate department to do the work for you. So you need really to, the only thing that makes sense when you start creating new departments is if those departments are either acting as service providers, meaning I'm going to make sure that Jenkins is up and running, but you're going to write your jobs. Or they're educating the rest of the teams, because the direction where we are moving as our industry is that everybody needs to know everything on a at least on a high level, right? You can specialize later into whatever you want to be specialized, but you need to understand the whole process. And part of that process, and the subject of this talk, is that you need to understand how to write your own pipelines. You need to understand how to write your own automation that will build it, test it, deploy it to production, what alerts you're going to have fired, and who of you is going to be paged on Saturday morning if something fails in production. So really no department, but education is the most critical thing. And that really goes well in hand with the first part, first commandment, that says remove silos and educate everybody to know what they're doing. The next thing is that you need to be small, right? Who works in a company that has a team of more than 10 people? How do you, you're very advanced, I like it. I like it. Usually I deal with applications that are maintained by 50 people, 20 people, 100 people for a single application. That's simply a nightmare, because we cannot move anywhere with such big teams, because that's not a team anymore. That's a school reunion, for example. So really, one of the things that you will experience, that you will have to do, is to jump on another hype, and that hype is called microservices. And microservices have many benefits that usually people don't speak about, and one of those benefits is that you can finally move with the small teams that can move all in their own different directions and different speeds. But there are others, like pipeline should last not more than 15 minutes. We're going to get to that commandment soon. And if the time is precious, if you cannot last for more than 10 minutes or 15 minutes, that means that actually the application needs to be small, because I need to build it in a couple of seconds. I need to run my unit tests in maybe 30 seconds, run all my functional tests in 2 minutes, performance tests in 5 minutes, and deploy it in 20 seconds, right? That's a reasonable time that we can allow ourselves. And we cannot accomplish that if our applications are huge, right? They need to be small, they need to be deployable by themselves, otherwise interdependencies are gonna kill you sooner or later. The next one is test-driven development. Who is, apart from people from Hungary, who is using test-driven development? You know what test-driven development is, right? Write your specification is test. Test defines what you're gonna do. You write your test, you run your test, it fails, you run your code, you write your code, run the test again, and it succeeds or it fails. If it fails, continue rewriting your code until it succeeds. It's not really a testing technique. It's a technique designed for defining architecture of our code better, with tests as a sub-product. It's a process more than the result. But anyway, if you're going to deploy often, so let's say that you're deploying every day or every hour, every minute, right? You cannot deploy to production every commit if it doesn't have tests. And so that means that you cannot write tests after you commit your code. It needs to be written in advance. Otherwise, what will happen is that your pipeline will never fail. It will always be green because there are no tests. So I move, test, test, test. I test nothing, right? I don't test new feature. Everything works, put to production. I have no idea what happened, right? So test needs to be written first. And in other words, what that really means is the developer comes last in a chain, right? So that commit done by developer is the last thing you do, and everything else is automated. And that is really conflicting with many organizations, because that means that whomever is in charge of testing, if that's not a developer, if that's a separate person, that person needs to write tests in advance instead of waiting for developer to develop a feature, and many other really drastic changes. So if you don't have tests, you cannot commit, right? And the only reasonable way to create tests in advance is test-driven development. If you can do it in some other way, that's still okay. But every single commit needs to have tests. If it doesn't have tests, that person should be fired or punished. Or it should give, I don't know, bring beer for a week to all teammates. So the next one is that once you master all this, and then none of those steps make sense if you didn't master previous commandments, right? And this one means that all your pipelines should be written as code. So those of you who are using Jenkins or some other tools might be used to freestyle jobs, or you go to a tool and you click, 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 and then you suddenly have a process that you think is automation, that somehow automated things. But what history of software teaches us is that for development processes, for end users are a separate story, but for development, code is the only thing that matters. The tools that help us, by clicking on them, they are disappearing. ESBs are disappeared from the scene, and Jenkins freestyle jobs also disappeared from the scene, and so on and so forth. And that puts us in a difficult position, because many of the teams that are in charge of those pipelines, in those departments that should not exist, they don't really know how to code. And that's a real pickle, because first it starts with serious questions. If you don't know how to code, why are you working in a software company? And if you do, when are you going to learn how to code? Because really, code is the way how we express everything. That's the way how we express our tests. That's the way how we express our features. And that's the way how we express whole automation of everything, including continuous deployment, integration, delivery pipelines. So then once we get to that part, we need to start speaking about the speed, right? How long a process from commit to production with all the steps in between and the steps after deploying to production, because you still need to even test even after you deploy to production, how long should it last? Now, I don't have exact number to tell you, whether it's this amount of minutes or that amount of minutes, but what I do know is that context switching is a very expensive operation, right? So if I start working on a new feature, and then I spend half an hour, day, whatever the time, working on it, and then I need to stop doing whatever I'm doing to fix my previous feature, because I just received 3 hours later notification that actually one of my tests failed, or build failed, or performance, something failed. If I need to stop what I'm doing, go back and fix what I did before, and come back and continue what I'm doing, I'm gonna spend half an hour probably trying to remember where was I. First of all, I'm gonna spend time remembering where was I with the previous feature that failed, and then when I fix it, I'm gonna spend a lot of time trying to catch up and to go back to the context of where I was before I was interrupted. Because realistically, what we do is complex, right? We are not doing simple stuff. We are doing our profession is very, very complex. And we need really a lot of concentration, unless your kind of job is to write getter-setters, right? Then you can be interrupted whenever you want. Then that's quite okay. But for most of the rest of us, our job is complex and we need concentration. And that means that we cannot be interrupted with failed tests, failed builds, and so on and so forth. And for that to accomplish, pipeline needs to be very fast. Now, I've said that I cannot tell you the number of minutes, how long it should last, but my measure of a fast pipeline is how much time you need to finish what you're doing, commit to the code, get up from your desk, go to a kitchen, get a coffee, maybe have a very short chat with a colleague on your way back, sit down and start working on something else. By that time, pipeline should be finished, and either you should fix it or start working on something else. So measure of time is coffee time, right? Now, if you're here, that's probably like 15 minutes, right? If it's in Spain, you go probably to a bar, and that's like 2 hours. So if you have a slow pipeline, I really recommend moving to Spain, because then you will have much longer period between for a coffee, or Portugal, for example. So next, bring us to the issue of when something fails, you need to fix it immediately. There is nothing more important than fixing a problem of a failed continuous delivery deployment pipeline. Except if, I don't know, if your building is burning or your mom is calling you to tell you about new Spanish soap opera, you cannot say no to your mom. Other than that, fixing pipeline always has absolutely the highest priority. And the reason is very simple, because if I committed something 10 minutes ago, and that something failed, fixing it will be no-brainer, because I spent, what, like 2 hours coding, committed it, 10 minutes later, I get a notification that it failed, and I'm gonna fix it in a minute, probably. Like, how hard can it be to fix something that I worked for a short period of time and finished working only a few minutes ago? If days pass or weeks pass, and then you find out about the problem, or then you start working on a problem, even though you found it out earlier, then it will be much more expensive, right? And that's one of the reasons why I really dislike tools like Sonar. Who's using SonarQube here? Right? It's horrible. And I know you disagree with me, but the reason why I think it's horrible, because it gives you excuses not to do things. Like, then companies make a rule, kind of like, oh, if more than 20% of tests fail, we should do something. No, if tests fail, you fix it. There is no real reason in our minds why we should look at some percentages and graphs and stuff like that. Either it works or it doesn't. If it doesn't work, you fix it. Or we're gonna use static formatting tools that will tell us whether our code has comments, and if more than 80% of the code doesn't have comment, then we're gonna do something. It's just silly, in my opinion. As I said, if you don't agree, I told you whom to address. This is not my message, is his. So, whenever something fails, you fix it, and only after you fix it, you can continue thinking about a new challenge. And after you think enough, then you can start even working on a new challenge. The next thing is that then companies go into a different direction and start relying on those tools like Jenkins or Bamboo, Travis, whatever you're using, too much. And then they start committing code without checking whether that code works. And I think that that's a huge mistake. You should, maybe not whole pipeline, but most of the pipeline should always be executed locally. So before you commit your code, run your builds, run your tests, do whatever it needs to be done, and then commit. And there are quite a few reasons. First of all, it's not that hard, because we already established that your pipeline, if you follow the commandments, is short, so you will not lose a lot of time doing it locally. On the other hand, you will do a really great favor to your colleagues, because you will not be committing shit. I'm not supposed to say shit, right? You will not commit bad code. You will not commit things that do not work. Now, we can never be 100% sure that it doesn't work, but at least we can have certain level of assurance that, okay, this most likely works. And then your tool, whichever tool you're using, is gonna do the rest of the work, or repeat the whole work and add some more. Of course, there are exceptions, like you might not wanna run performance tests on your laptop. And maybe you don't want to do exploratory tests on your laptop, but everything else, really, there is no reason why laptops. I mean, they have 16 gigabytes today, right? Almost each one of your laptops has 16 gigabytes. You can run everything you need to do whatever you need to do before you commit your code. And this is the one that actually usually, and we're closing to the end, usually people freak out. If you want to adopt continuous integration, delivery, deployment processes, that means that you can have only master branch. You cannot have branches. I mean, you can have branches, but they must be short-lived. So if you make a feature branch and say, I develop there, and after a few hours or a day, I merge it to the master, it's okay, that's the same thing almost as if you have only master, right? But you cannot say, I create a branch, and then a week later or a month later, I'm gonna merge it to master, and I'm gonna do continuous something, right? Because there is nothing continuous about waiting for a month. That's completely against the definition of the word. You can call it delayed integration, for example. Or we can invent some other name, right? But it needs to be master is the only thing that matters. And when you think about it, why would you not commit directly to master? What is the reason? You don't trust your tests? If you don't trust your tests, then you most likely don't trust your testers either, because actually they're doing exactly the same thing every day. Excluding exploratory testing, that's a different issue. So if you don't trust your tests, you're going to fail no matter whether you use branches or you don't use branches, and quite a few other things. So really, the master branch is the only thing that matters, and that's how, like, really those Silicon Valley type of companies that don't disappear after 2 months are doing things these days. Master directly. Unless you're the only exception actually there are 2 exceptions to committing directly to master. First of all, if you live in 1999, and most companies do. And the second one, if you're an open source project, because that has a pretty different rhythm than non-open source projects, right? Because of the contributions, and you don't know who you work with, there are no teams and all those things. So him, not me, said, thou shalt be agile. First, before you try to do anything else, thou shalt refactor your code and make it meaningful, make it, or don't touch it. That's also another good strategy. If you have something old that you don't want to improve, then don't. Just leave it rusting there, right? If you work in a bank, COBOL, it sits in a corner, that's okay. I don't touch you, you don't touch me, that's okay. But for everything else, you really, really need to refactor your code. You need to educate everybody. I'm talking today about continuous delivery, continuous deployment, but that applies to almost anything. People, every single member of your team needs to know the big picture, needs to know what is a database, it needs to know how to deploy things. Because if you don't know how to do everything, and I'm not saying everything to be a master ninja expert, but at least on a high level, if you don't understand the process on a high level, then whatever you're doing is going to be wrong, because you will not take into account the rest of the process, of the rest of what is required to have things in production. Those shall be small. This is easy one. Teams of 6 to 8 people. Everything bigger than that, it's I don't know, it's an airplane or it's a school reunion. It's not a software development team. And when I say small, 6 to 8, I don't mean 6 to 8 testers and then 6 to 8 developers and then 6 to 8 operators. I mean 6 to 8 people that are fully self-sufficient in charge of a single service. They know how to do everything from a requirement all the way until production and monitoring, right? And to do that, your applications needs to be small, manageable. If they are huge, you cannot do it. You should practice TDD, test-driven development. It's been 20 years, no, not 20, maybe 15 years. It's about time. And if you listen to Ruby on Rails guys, that they say that TDD sucks, that's because their language sucks, not because of TDD. You should define your continuous deployment pipeline as code. Not clickety-click, not going there and creating jobs by selecting plugins and then choosing different options. Everything is code these days, and this applies to continuous deployment pipeline. It must be fast. So time to get coffee, drink it, come back, continue working on something new, 15 minutes in Zagreb, 2 hours in Spain. When something doesn't work, you fix it. It's that easy. You don't accumulate problems until the next sprint, until next month, until next year, or whatever you're doing. You fix the problem, then you move on. You don't move on with problems behind you. You run everything locally, you build almost everything locally, you build your application, you run your tests, you do whatever you need to do, and then you commit, and that way you respect your coworkers, and when they fork your code, you know what fork is. Now, if you tell me that you don't know what forking is, then I'm going home. Really? Okay. Uh, when they fork your code, it will simply most likely work. Not necessarily always, but most likely. And you will commit only to master branch. You will have no branches, or those branches will be very short-lived. Make a script that removes all branches older than a day. And that's it. If you don't, when he says, again, it's not my word, it's his, you know what happens. World of Warcraft, probably. Hell, something. So, I tried to speak relatively fast, maybe confused you, maybe not, because I like to dedicate like at least 1/3 of a talk to questions. And before questions, this is me, Twitter, if you want to follow. This is my blog, if you want to read. These are the courses if you want to attend. These are videos if you want to watch. And these are books that you must buy if you want to be proficient. And then I will like you more. Questions? Don't tell me you have no questions, because then I would speak longer. Eight to 10 minutes. Let me show you. You were not following. You were not following. Wait. You were not following. Here you go. Huh? That's. I mean, I have a very important philosophy that I try to follow. Change the company or change the company. Meaning, if you can change how the company works, great. If you cannot, then change the company where you work, and the problem solved. Our lifespan is very short. Don't waste your time if you don't have to. So, if you want, we can discuss the art in more length. Any other question? Yes. Depends. If I would be in your company, I would go full throttle. I'm kidding. No, it's a process. It's a long process, and I cannot give you a formula kind of, this works for everybody, because it depends which parts of your, more often culture than technology needs to be fixed. It depends how you're organized. It depends how your code is. It depends on your departments. I cannot tell you, but nightly build is better than monthly. I can tell you that much. Because I assume that your nightly builds are because it takes hours, right? You have nightly builds, you said? Or you want to go have nightly, right? I mean, the only reason why, so let's put it this way. Why would we have nightly builds? Let me answer with the question. Why would you have nightly builds and not on every commit? Because you don't want to waste CPU and memory of some machines. So let them not get too tired and do it multiple times a day. Let them do it once a day. It's machines. They can do multiple things during the day. It doesn't have to be one nightly build. It can be on every commit. The more important question is whether you should do continuous integration, delivery, or deployment, right? And if you have nothing, you should start with continuous integration and do it on every commit, right? Unless you need 57 servers to execute your pipeline, and it takes 78 hours. Then you should do nightly. Now, that should be weekly then, something like that. Sure. Okay. Yeah, but I would say that you cannot really organize your work in a way to say, look, it takes exactly 8 hours a day to develop something meaningful. I would say that sometimes it takes you 15 minutes to develop something meaningful. Sometimes it takes you, God forgive, 2 days, right? But to me, it's not related. It's not about how often you run your pipeline. It's how often do you do something meaningful, and you commit to repository and validate whether that meaningful is really meaningful or a big pile of art, right? So I really don't. All the reasons that you said, I think that they're equally valid or even more valid. So instead of fighting who broke the code in the morning, why not just who did the commit and broke something, and that person receives Slack notification or whatever you're using and says, okay, your commit doesn't work. Any other question? Yes. Yes. It depends on quite a few things. It depends first how much that company wants to do that or no. If it doesn't want to, then it's pointless. If and when I say company, I mean decision makers. I was very enthusiastic when I was young, and I tried to change the world from bottom up, and that doesn't work because you hit the ceiling sooner or later. So I usually now go to higher instances. So first step is I need to get a buyout, right? So you'd really, really want this, whatever that is, right? And if I have a buyout, that means that I have somebody behind me that can actually back me up. And then in case of highly regulated, I don't work that much with industries you mentioned, but I work a lot with banks, for example, and that's the same thing. And we usually try to, one of my first steps is to try to work with them to distinguish the objectives of regulations from prescribed practices behind those regulations, right? Because usually objectives are somehow lost in most companies in a picture and say, no, you need to do A, B, C. Instead of the end result must be this. Like you cannot deploy to production if software vulnerabilities, if your software is not scanned for software vulnerabilities, right? That's not the same as saying you cannot go to production unless you open a Jira ticket and send it to this department, right? That's quite different. And once we establish what we wanted, what are the real objectives behind whatever regulations, then we try to figure out how we can accomplish them, right? And that sometimes means working with this department, that department, but usually most important thing is to be sure that every single member of that organization understands what those regulation objectives are. Because it's usually the problem is, okay, I'm going to develop something for 3 months, and then I send it to some department for regulation XY, and they say this is shit. Actually, it should be the other way around. All those things should be part of the process. So I need to know what are the objectives, and regulations are one of them, and I can develop with that. And those departments should be helping me, not acting as a police, kind of like, wait. Now it's my turn. No, so I think it's very important to try to go. I repeated quite a few times that everybody needs to know everything, at least on a high level. All those processes and culture needs to be ingrained in a team, not separated into silos. And it's very hard to change that. I mean, changing silos, changing culture. Usually people start kind of, our problem is, I don't know, how are we going to deploy, I don't know, how are we going to adopt Docker? That's not your problem. How you're going to change your organization, that's a real challenge, usually. Did I answer your question? I even forgot what it was. But if I did, then that's good. Yes?
Okay, so this seems very sane and doable for like new projects and new teams. Have you ever witnessed like overreaching piece of software with these changes adopted and switched to continuous integration?
Yes, but it's a very horrible and long process. I don't know. This machine doesn't. It's Windows. Sorry, but yeah,
If you witnessed multiple cases of that success, what would be like the most important ingredient?
culture always.
It's a commitment to doing
It's a commitment to
this.
doing something and accepting that. So actually, it's not even that much culture. The main problem is usually power struggle, right? Because let's say that if you're a development department and you're operations department, right? You have your objectives, you have all your own power company within company, right? And if I tell you now you're gonna all mix, then suddenly some people start getting afraid for their positions, whether they're gonna be equally high or low and stuff. It's usually power struggle because I think that almost every company that is more than 100 people big, they have multiple companies in a companies with multiple objectives.
So what would you say? I'm sorry,
Sure, sure, sure.
what would you say success ratio of those attempts? Is it like 50%, 10%, 5%?
I don't know percentage, but I think that closer to 10%. No, because what is happening, according to my criteria, according to their criteria, 99. Because what happens is that companies, yeah, exactly, kind of like the biggest evil in that story is Gartner. I don't, you know, Gartner company who gives, so, huh? Yeah, I mean, or Gartner-like companies. And then big companies, their CTOs go to Gartner meeting or alike every year, and then Gartner says, this year you're gonna become agile. And then they make an agile transformation project, and at the end of the year, they put a sticker, we are agile now, excellent, we are all fine, and now go to another meeting and say big data, now continues this, and then DevOps. Now this year's all hype is DevOps. Everybody is employing DevOps engineers. Such a thing does not exist. And having a DevOps department is contradictory to everything that DevOps tries to accomplish, right? But, and then they put a sticker, say I succeeded, right? The thing is that for big companies, and I'm inventing, I cannot back this with data, but I think it's more likely that they're gonna disappear as a company than change. Actually, the rate of change is also changing drastically. If you look at, I don't remember the exact figures, but like 15 years ago, Fortune 500s, and look at Fortune 500s today, there are almost no matches, like they disappeared. Regulated industry is a bit special because usually there is government involved and bribery involved and politics involved, and you cannot actually disappear as a business because regulations that prevent competitors from coming in the first place. But yeah, no, not a very, not a high success rate when you look at it objectively. When you look at it, how they declare it, very high. I cannot name the companies, that's kind of, but also it's a very high rate in disappearing companies, just to make sure. Not only kind of like they don't succeed and they continue. No, they don't succeed and fail. And then I mean, they still exist, but where will be television companies in 5 years? They will not exist. Where are taxi companies? Where are Airbnb, ate half of the other business? I mean, they're disappearing.
And would you say software startups are embracing this type of
Yeah, because
they are faster this way and more?
first of all, it's much easier when you don't have baggage behind you. It's very, one of the hardest part is to unlearn, kind of like, if you do something for 10 years in a certain way, changing that is much harder than taking somebody who knows nothing and then moving him forward. So startups are, in most cases, in my experience, but I'm always talking about my personal experience. I don't know worldwide statistics. Of course, startups are better, right? But on the other hand, at least in US, I think that, again, I don't remember exact figures, but 1 out of 10 startups survives a year. So it's not that startups are successful. It's just that there is a different culture and most of them fail, and then those that succeed become multi-billion-dollar companies. Any other question? because you should fail when a test fails. I don't care about it's so it's to me it's kind of like I don't think that so let's say that we start a new company from scratch, right? I write my first feature and it produces one failed test. It's all okay because it's still only one, right? And then I'm gonna move and they say, okay, you should fail build when you reach 10. That's wrong. You should fail build whenever it fails. And tests. If you don't write tests, then what's the point of sonar? I mean, what what is the point of statistics if you don't have data?
When you are in a migration, kind of you move to a new framework, you are introducing new practices to other teams.
Yeah.
And you say you should build microservices. You should set up these standards. Tests must always pass 100%, or the build must fail. But the Sonar offers you code style, technical depth. You're not using try catch, where there's possibly dangers in code. And basically, I guess that's the question.
So,
You set up a quality gate, but it's not 100%.
okay, I agree with that. So what I could agree is to say, let's say try-catch statements, to limit the scope, right? And say, how many try-catch statements we have today? 575, right? And if you're gonna set Sonar that anything above 575 fails the build, then you're fine. Meaning that, okay, we accept that we have shit, but we're not gonna introduce a single new piece of shit again. So if that's the purpose, then yes, I'm all for it, on it, yeah. Yeah, sorry, I misunderstood. If your question is, yeah, code coverage is a nonsense. I hate code coverage. Because code coverage is a good learning technique. If you want to learn test-driven development, code coverage is great, right? Because it teaches you what did you miss and stuff like that. But once you get proficient with it, you say, okay, I wrote a test, I wrote a piece of code that passes the test and no more, and why do I care about code coverage? It's always high. I know it's high. I'm not going to even look at it, right? If it's a learning technique, great, right? Just as a side story, and I swear to everything that I did not invent what I'm going to say, I was involved. I hope that you said force because English is not your strong point, not because you meant. No, not force. Why would we want to force? No, we want to educate people how to do things right. We don't. We shouldn't. So when we force people, then we behave in the same way as how some people behave with their children. Kind of like you cannot cross the street. You cannot cross the street. Instead of telling, hey, you know, if you cross the street, you're going to be hit by a car. Go ahead and see how it looks like. Right? So, okay, don't go that far with your children. But what I want to say, we shouldn't treat children like with those gates, kind of like people like children. Okay, if I understand what is the value to me of something, I'm going to apply it. I would need to be insane not to apply something that brings value to me. So if you explain me what is the value, I'm going to do it. If you force me into something, I'm going to change the company. This is, so I was involved in a project. Sorry, I was not involved, but my company was involved in a project, and I knew a lot about it. So a customer says, I want 80% to make a project with external company, ours, 80% code coverage of code coverage, right? And our company says, 80%, 95. 95. And they did it. They managed to make a code coverage of 95%. There was not a single assert in that project. Not a single assert. Because you want stupid thing, you got stupid thing. You want code coverage, we wrote a shitload of tests that just invoke a function, right? It goes through a function. No, really. And actually it was very hard because code was awful, so we could not manage 100% because there are always a special, try catch that, and you cannot actually reproduce that exception. So it's not hard, it was not easy to get even to 95%. But there are no assets, eh? So what you get is what you ask for is what you get. Yes. Yeah, so if so, yeah, I was harsh at the beginning. If your gates are saying we have this shit, but we don't create more shit, and probably with time we actually lower those percentages, then it's great. Then that's fine. I'm fine with it. Yes. Yes. Sure. Exactly. That's exactly. I mean, that's why I said it's a kind of learning technique because once you adopt, I'm prickish about TDD, and I never write anything beyond the test, right? So kind of like there is no unused almost. There are some special corner cases, something you can, but yeah, you're right. But to me, that falls into learning technique type of. And yes, if you say I'm happy with those tests, and your CTO says we are happy with those tests, they cover everything. Feel free to remove any code that actually. Yeah, really. And lack of tests is one of probably the main reason why companies are not modernizing their stacks is the lack of tests. Because if I have an application that does not have reliable tests, how am I going to refactor it? You cannot touch it, exactly. And that's also okay. What I'm not very okay much with, I want to touch it, but I don't want to touch it type of attitude. No, kind of leave it rotting. Let's focus our energy on something that, exactly. I know. I've been, for a long time, I changed companies often, but in one of my previous companies, they were always calling me whenever there is something kind of to teach and preach about testing. And I had quite a few cases where they told me, okay, hey, can Viktor come and teach us how to do tests? And then after that, I told them, no, don't test. This is untestable. It's a waste of time. And it really is. Automated tests are very often a waste of time. Because if it's not created to be testable, it's a waste. Exactly. Anybody else? No?
The music is starting.
Ah.
There is another question.
No, I didn't. I never said this. It's recorded. It's recorded. Don't tell me. I work for Jenkins. My company is the company behind Jenkins. I can tell you that I dislike it after cameras, but not now. Yes, there are so Jenkins traditionally for years used freestyle jobs, and it's been like 4 years where we move to a pipeline, and there is scripted pipeline, declarative pipeline. There are different flavors, but they're all code. So the freestyle jobs, huh? It's not infrastructure, but infrastructure as code as well. Everything is code. Everything is code. Like infrastructure is, I mean, that's not really Jenkins. But yes, I mean, use Terraform. Don't go to AWS and say click, 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 click. That's not reproducible. That's awful. But yeah, in case of Jenkins, adopt the Jenkins pipeline. Use a multi-branch pipeline. Jenkins file in your repository, not in Jenkins. I'm not doing marketing, so we can speak about Jenkins later.
I think just for all versions of Jenkins stuff.
Yeah.
Only for a reason you can install new stuff as plugins if you want.
Yeah, but it's going back to refactoring. Why is the kind of no, not you. I mean, the problem is if you don't refactor. I use refactor now in a very generic terms. That can be upgrade of software, right? So if you don't refactor for a long time, then actually it becomes too expensive. So if you don't upgrade Jenkins after 2 years, then you say, oh, now if I upgrade, actually I will need to spend 3 months fixing the problems. But when that is more or less continuous, when I say continuous, depending on the task, it can be every day or every hour or every month or a year, right? But just upgrade often. Was this the last question? Do I have time for more questions, Rocco?
You have all the time in the world.
I have beer, so depends on them. Is this my beer?
Yeah, it's yours.
Okay.
I have a question for you.
Yeah.
Will you come next year?
If you invite me.
We will.
If you invite me, yeah.
Because the total sum of questions that and the discussion that you engaged here is larger than the sum of all other lecturers.
No, I love coming. I love the conference to begin with. And
You will be the first to get an invite. Guys, please thank Viktor Farčić.
Thank you, guys.